We're going to look at how to find a unit vector in a specific direction. This comes in very useful when we talk about the concept of work, the physical concept of work, and other reasons as well. So we know that unit vector, unit means length of 1, and we want to find the unit vector in the direction of vector A. So first of all, let's prove to ourselves that vector A is not a unit vector. So the magnitude of A is equal to the square root of 4 squared plus 3 squared, and that's one of our triplets. So we have the magnitude of A is 5. So the overall length of A, this A vector, is 5. So A is not a unit vector, but we want to find the unit vector. We want to find the unit vector that's in that direction. So we want to find this little vector. It's in the direction of A, and it has a length of 1. So we'll call that little vector A hat, because we know that little hat means length of 1. Well, in order to find A hat, it's actually a very quick procedure. All you do is you take vector A and you divide it by the magnitude of A. Now, anytime you see vector A, you can rewrite that as its component form. So we're going to take 4, 3, and we're going to divide it by 5. And so the 5 goes into both of those components, and we get 4/5 and 3/5. Or if we wanted to write it as a decimal, we could. These are terminating decimals, 0.8 and 0.6. Now let's prove to ourselves that that is a unit vector, right? So let's make sure that we believe that this is A hat. And so we'll look and check, is the square root of 4/5 squared, or 0.8 squared, plus 3/5 squared, is that equal to 1? Because that's how you prove something's a unit vector. And so we get the square root of 16 over 25 plus 9 over 25, and yes, that's going to equal 1. So our little A hat vector, that is 4/5, 3/5. That is the vector that has a length of 1 that is in the direction of vector A. Okay, so let's do it again now for vector B. Again, when we want to find a unit vector, so the general formula I'll put down here at the bottom. So V hat, unit vector in the direction of V, is going to equal the overall vector V divided by the magnitude of vector V. Okay, so if we want to find the unit vector in the direction of the vector B, we're looking for that little unit vector that has a length of 1, going right down on this B vector. So we have to find the magnitude of B. So the magnitude of B is equal to the square root of 2 squared plus 6 squared. Again, I drop the negatives because when you square them, they become positives anyways. And I get the square root of 4 plus 36 is 40. And we want to simplify that. That's 2 radical 10, because this is 4 times 10, and the square root of 4 is 2. And so B hat, the unit vector in the direction of B, so that's little b hat, that's going to equal vector B divided by the magnitude of vector B. And so that's going to equal -2, -6, divided by 2 root 40, 2 root 10 rather. And when I put that into the vector, it becomes -2 over 2 root 10. -6 over 2 root 10. And let's clean this up a little. So -2 divided by -2, we get -1 over root 10. And -6 divided by -2 is -3 over root 10. And if we rationalize the denominator, the final answer for this one, the cleanest answer would be -root 10 over 10, -3 root 10 over 10. But again, I haven't made you rationalize denominators a lot. With calculators, these both are equivalent in terms of usefulness. So B hat can be written, these are equivalent. This is rationalized denominator. And that's how you find a unit vector in the direction of a vector.